Okay, so this is just acetone. We're going to put this in a vacuum pump. I'm going to remove the air. So I'm going to try and make it boil. Okay? Try and make it boil. So when something's boiling, what are you breaking? Intramolecular bonds or intermolecular bonds? Inter. So if something's going to boil, you're going to change it from a liquid state into a gaseous state. So it's going to have the same number of particles, but instead of being bound together, and remember there's two types of energy, you have the attractive energy and you have kinetic energy. So in a liquid, the two energies are about the same, okay? Well, when something's going to boil, the kinetic energy, the energy of motion, becomes much greater than the attractive force. So right now, everything's in equilibrium. There's pressure created by an atmosphere. Inside of there, there's nitrogen, oxygen that are bouncing around. And so if you look at the interface of the surface of that liquid and the pressure and the atmosphere up above, so right now, everything's kind of in equilibrium. So there's pressure pushing down on the top of that surface. So it's like kind of like keeping a lid on a group of second graders. It's like they really want to go free and go running around. If you're the teacher, you're like, hey, I know it's close to the end of the year. Let's keep a little bit of lid on this whole thing. Okay? So what I'm going to do is I'm going to remove the air that's on top of it. So in somewhat analogous to a second grade class, I'm going to take them outside. Okay? I'm going to remove the confines of the normal classroom. So I'm going to see if I can make it boil without adding heat. Okay? So that's the challenge. Can I make it boil without adding heat? So.
Is that why in the vacuum space our blood moves?
Kind of. I know that one. Okay. So, if you come over here and look, you're going to see that this stuff is boiling, okay? You're going to see bubbles coming up towards the top. So this is like taking a second grade class outside. So by definition, boiling is breaking these bonds. So what's happening is that I don't have the pressure up above that's keeping that down. So by removing that pressure up above, now they're going, oh, we're going to jiggle around, and now we can turn into a vapor. So I'm making this stuff boil without adding heat to it. Now, if I'm going to release this back in, okay? So when I did that, that equalized that pressure again. So I'm also going to try and make it pressure, or make it boil, within a syringe. So I'm going to take this, okay? So there's my acetone. I'm going to pull my finger, put my finger over the top of it, and I'm going to pull this down, okay? So if I do that, and I pull that down, what do you notice happening? It's boiling, okay? So this is just a smaller version of what I just did. So when I pull that down, okay, you'll see that that begins to boil because of the fact that it's the same idea. So these particles are held together. They're held together as a liquid. So when I pull that down and I increase the volume, what's going to happen to the pressure?
Decrease the volume?
Yeah, no, so I'm going to increase that volume and pull this down.
Decrease the pressure.
Yeah, I decrease the pressure. So if I decrease the pressure, then what's happening is that those bonds are easier to break, okay, because I don't have the pressure kind of like keeping the lid on it. So I pull that down, boom, I just made something boil without adding any thermal energy to it because of the fact that now I can break those bonds. Got it? Good, Grant? Okay, back we go.
So in reality, it's really just doing